In this video, we'll take a look at the first law of thermodynamics applied to cycles. We'll also see how thermally insulated bottles like Yeti bottles work, and we'll look at the similarity between fire syringes and diesel engines. So to start off, we'll take a look at cycles, and we'll use a PV diagram to represent the cycle. So pressure in kilopascals, and we'll have volume in meters cubed. And for a cycle, we start at some specific state. We have some process path that brings us back to that state. And if we write down the first law of thermodynamics, the change in energy is equal to the heat interaction minus the work interaction. We also know that the change in energy is just equal to the final energy minus the initial energy. Now, because we're in a cycle, the final energy after we go through the process path is actually going to be equal to the initial energy. So this, we know the difference is going to be equal to 0. So the change in energy is equal to 0. And this implies that the heat interaction is actually equal to the work interaction. Now, to better visualize this, I'll pull up a diagram of a Stirling heat engine. So this is just a Giphy produced by Banggood. And on this right-hand side, there's a bunch of complicated stuff, but we're mainly interested just on our system, which we'll just analyze as the heat engine, and this is a heat source. So this could be a flame, this is just anything that could add heat, and this is just heating up the air inside of this piston chamber and causing it to expand, and then there's some other things on the right-hand side that cause it to contract. But our main interest is that this is a cycle, so it repeats itself in various different states, and because it's a cycle and there's a heat source, we know from the first law that the total change in energy of the system is going to be 0. And that means that the heat interaction is going to be equal to the work interaction. So what this actually means is whatever heat we're giving off here is equal to the work interaction that this whole system is going to have with the environment. Cool. Now we'll move on to adiabatic processes. So what is an adiabatic process? And this is just any process where the heat interaction doesn't exist, so it's equal to 0 kilojoules. And we'll take a look at the first law to better see what this means. So we have that change in energy is equal to heat interaction minus the work interaction. Because this heat interaction is 0, we know that the change in energy is actually just going to be equal to the negative work interaction. Now, when does an adiabatic process even happen? So let's look at a Yeti bottle. So if we have a bottle, and let's say we're drinking some hot cocoa. So in this bottle we have some hot cocoa, and then this is our surroundings. If we take in a zoomed in portion of the wall of our bottle, so we're zooming in on a wall, we'll actually see that the wall is composed of 2 layers. So there's 2 like metal sheets, and this part over here is our surroundings. These walls continue to extend, and we have the coffee inside of the bottle. And in between these 2 sheets of metal is a vacuum, actually. So there's no air particles. And this allows the movement of the particles inside of the hot chocolate to stay within the wall, the first wall, so that there's no transfer of energy from the hot chocolate into the surroundings. And this keeps that heat inside of the thermos bottle. So that is pretty much a general overview of thermal insulation. Next, we'll take a look at a fire syringe. And it's called a fire syringe because it has some syringe. So you can think of it as a piston chamber where there's a piston over here. And we'll have continuation of the piston over here. And this whole thing we'll just call a fire syringe. So you can look up videos of a fire syringe. And what this fire syringe does is it has a little piece of cotton at the bottom or some other material, and work is applied to the piston. So if we look at the first law, so change in energy is equal to that heat interaction minus the work interaction. The heat interaction is non-existent because we're just applying work, and the stuff inside the piston, the air inside the piston, is at the same temperature as the air in the surroundings. So there's no heat interaction. We have this work interaction. Now this is not a positive work, would be work done by the system, but this is work done on the system. So this work is actually this work, this number right here, that's going to be negative. So there's negative in front, so we know that this change in energy is going to be whatever absolute value of the work interaction is. And this kind of makes sense. If you're putting work, if you're pushing on the piston, then you're doing work on the system, and so you're adding energy to the system. But essentially what happens is if you push this piston really fast, then the air inside of this piston, so the little air molecules in here, get compressed at a very high speed, and so the pressure increases, the temperature increases, and it actually causes this cotton ball to catch on fire. That's why it's called a fire syringe. So that's pretty cool. The thing is that's special about this fire syringe is that this work interaction must be very fast. If you slowly push on the piston, then the air does heat up, right? So the air is still heating up, but instead, as it's heating up, it's also dissipating heat into the surroundings. If you push on it slowly, the heat will go into the surroundings. But if you push it very fast, then the heat doesn't have enough time, or doesn't even have a chance to go out into the surroundings from within our piston chamber system. So this fire syringe is actually pretty similar to how a diesel engine works. So if we have our little diesel engine, so we'll just write diesel over here, and we have that piston chamber. We also have that piston, and it's just the end of the piston. We'll go ahead and draw the second phase. And so this is just when the piston is compressed, and we still have that continuation of the piston. And we'll say this is our first instance, and this is our second instance. And what happens in a diesel engine on a very high level scale is we have a little fuel injector right here. So this thing just puts in fuel at a very high pressure, and we'll learn more about diesel engines in detail in another video. But essentially, this piston is pushed down, and it compresses the air within the piston over here. So the air is compressed over here, similar to how our fire syringe compressed the air. So this air gets pretty hot, and then this fuel injector essentially just sprays some diesel fuel, and this causes an explosion, essentially a mini explosion. Causes a mini explosion here, a lot of heat, and this drives the piston back up. And that is a general idea of how a diesel engine works. Thanks for joining me on this video. I'll see you in the next one.